it really just kind of boils down to what kinds of risks are we going to take seriously or not.
Welcome to the LabVIEW Experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes.
Hey listeners, today we're doing something a little bit different. We have broken this episode up into two parts because Sam and JB talked for over 2 hours. And we hope you enjoy part one. Part two will be out in 2 weeks.
I am here today with JB Rainsberger. You may have heard me mention him before. He gave a talk a while ago called The Economics of Software Development, and I definitely posted a lot about that at the time. So welcome, JB.
Thanks very much for having me, Sam. I appreciate the chance to have a chat with you today.
Yeah, so let's start with the economics of software development because that, to me, is probably one of the most influential talks I've listened to.
Oh, wow. Thank you.
I feel like I was already kind of thinking along those lines, but it put in words a lot of the stuff that I was thinking and made it a lot clearer. So,
yeah, that's definitely one of those ones that came about. You know, when you wander around and try to help people, you sort of build up pieces of ideas that gradually start to fit together. And especially when you start saying the same things over and over to different clients or to different people that you meet, eventually they get ironed out into bits, and then those bits come together and you start to notice that maybe there's a theme. And that's really how that one came about. The hardest part was finding a place to start. And then once you start, then the ideas just sort of flow one from the next. I'm really curious because it's been a long time since I've thought, and I've done a version of that talk in a handful of places. There are at least 2, maybe 3 different versions of it, at least in part on YouTube. What do you remember from it as being particularly influential for you?
I like the lowering the marginal cost of adding new features. I think that was interesting. And not even so much like that phrase necessarily, but just the idea of trying to put things into the language that the business people can understand. And then also just that whole, like, we're actually on the same side. Thought that was interesting. And the other one that I've seen other people do and is the graph of like, okay, if we do things quick and dirty, yes, we start, things start off faster, but then they quickly decay versus the other one where, that if we do it right, it takes longer to get off the ground, but we move at a better pace. And then the very interesting part of that is that you never know where those two curves intersect, which I found was the most interesting part.
That's kind of my favorite part. So the business and the programmers are on the same side, for viewers. That's really about sort of the classic apparent conflict between business people who want features and programmers who want to refactor. And they think that they're in conflict with each other when what it really turns out that they're actually on the same side. And what they're both trying to do is to get a predictable, fast flow of features into production, into the hands of real users who can use them. And I think what the business folks don't seem to get is that when programmers want to refactor, they're typically trying to protect their own capacity to continue delivering features. And that's where that phrase, I remember one day I was really struggling with how in the world can I help a business person understand this concept? Like, because it seems like it just seems like a smoke screen, right? It seems like we're saying, hey, trust us, bro. When we refactor, it allows us to deliver features sooner. And I really had no way of proving that didn't require a lengthy discussion, which became part of that talk. And so I was trying to really sit down and figure out, like, how can I say this in a sentence? And so I stumbled around. I had, pages and pages of ideas until I finally hit on well, we're just trying to lower the marginal cost. We're just trying to lower volatility in the marginal cost of features. Isn't that what you want? And I remember when I first said lower the marginal cost of features. And then I realized that's not quite right. We're not necessarily trying to lower the marginal cost of features, but we're trying to make it more predictable. So how can I make that sound even more impressive? I know, lowering the volatility. We're trying to reduce the volatility in the marginal cost of features. Don't you want that? And the beauty of that phrase is, as you said, because we are framing it in economics, business language, like one of the immediate ideas is that's supposed to provide shock value so that the other person listening to the programmer first goes, whoa, like, did I actually hear a programmer use those words? I didn't even know they knew what those words meant. And then the second thing is once they get past that and sort of have the vague idea, oh, this programmer speaks a little bit of business, maybe I should pay attention. Then we can get into what does that really mean? Okay, I'm trying to make the flow of features more predictable, the cost of the upcoming features more predictable. And then it turns out by accident, if you make the marginal cost of features more predictable, it tends to get lower. That's part of what actually makes it more predictable. So by reducing the volatility in this measure of the cost of future features, it tends to make future features less expensive, which is what the business person thinks they want. But I mean, after 25 years of trying to tell people I can't give you cheaper features and here are the reasons why, they typically will settle for, well, I just need to know when they're coming so I can plan. Okay, cool. Let's focus on trying to make the cost of features more predictable so you can plan. And I'm willing to bet you that if we manage to succeed in that direction, even just non-trivially, you'll notice that the cost actually goes down. Because the things we need to do to reduce the volatility are the kinds of things that will get rid of unnecessary steps and do a better job of getting feedback about the quality of the software and avoid letting mistakes sit there for long times undiscovered. Allow us to see mistakes sooner after we make them, and all those things actually make us deliver sooner. So we get it's funny, we get what they think they want, even though what they really want is the thing we're going to give them. And if we give them the thing they really want, then we will accidentally give them the thing they think they want. So everybody wins. And that was sort of that was for me like the first big light bulb moment. Like, I think I have something here. If I can figure out how to tell stories about this that will sound reasonable and compelling, then I think people will actually really care about this idea. And the whole graphs thing, I love the graphs thing because it allows me to put an equation between two integrals on a whiteboard. And I have to say, the first time that I did that in front of a room full of programmers, I had to laugh at how utterly ridiculous it is, but also how effective it is to the 18 people in the crowd who understand integrals, who remember enough to know what that really means. Anytime you can dazzle them with a little bit of technical language, it's something that will help them pay a little bit more attention. So even if it doesn't do anything to actually lend credibility to the ideas, if it'll help them, if a little bit of smoke and a little bit of sizzle will make them pay attention more, and that's part of what makes these ideas stick.
So I think Andrea Goulet. She does the
Yes.
empathy and tech stuff. Yeah, I got on my empathy and tech t-shirt on that. Maybe you can see it. She asked me to do a talk, and I really liked your talk, and I was like, I want to do a talk about the economics of software development. And my initial thought was like, well, I'll just redo a JB's talk because more people need to see it. And I was like, well, that's really dumb because I can just send them the video, and JB
Right.
does a much better job than I'm going to do. So I tried to figure out how can I come up with a unique take on it. And part of my take, and you can tell me if this resonates or works or not, but I do a lot of rock climbing and outdoor stuff, and it's all about managing risk. And as a business owner, I feel like there's a lot of managing risk. So I thought, let's make that connection and try to treat okay, we can do this, we can go faster, but we're taking this risk on at the same time, and try to work that metaphor. Does that that seem to resonate? Do you think that's
Oh yeah, absolutely. When I remember when I first started teaching test-driven development 20 years ago, I was doing some work with Pat Wilson Welsh. He and I were co-teaching some courses at the time, and he actually used the rock climbing analogy more narrowly with the whole, your the sort of ratchet effect that you get from writing tests and making them pass one at a time and just sort of building on a solid foundation one step at a time is not dissimilar to some of the safety stuff that you do when you're rock climbing, so that, for example, when you fall safely, you fall a not
Mhm.
disastrous distance, and that on the one hand, if you just went for it, you could probably climb the rock a lot more quickly. But it seems like we take risks more seriously when the cost of failure is severe injury or death than when it's, oh, our project is late by 2 months, or a CEO somewhere is going to yell, or an impatient customer somewhere is going to threaten a lawsuit. So it really just kind of boils down to what kinds of risks are we going to take seriously or not. And actually, the whole risk management thing is one of the key points of that talk was we have a tendency to say manage risks and then gloss over what that really means, how we actually do it. Most people don't want to get a PhD in risk management to get started. They kind of want some idea of what might help them. And that's where, again, in a talk like that, where a little bit of mathematics goes a long way, being able to tell people about like the basic way of measuring exposure, about multiplying the cost of failure by the probability of failure, and then adding that up for all the risks that you identify, and just make sure you have that much money in the bank or that much of an insurance policy, really goes a long way to helping people go beyond just, yeah, JB says you should manage risks, or Sam says you need to manage risks, but what does that actually, like, cool story, bro. How do I get started? What am I supposed to actually do with that? And one of the nice things about the risk management angle is if you tell them about exposure and this idea of multiplying the probability of failure by the cost of failure and make sure you have that much money in the bank, now all of a sudden there are two main strategies for dealing with any risk. And one of them is to try to drive the probability of failure down to zero, which is what most people do. And the other is trying to drive the cost of failure down to zero. Because if the cost of failure is pretty close to zero, you can screw up as much as you want. That's kind of the beauty of it. That's what makes a lot of the ideas in extreme programming and in other forms of agile software development, that's what gives them some teeth, is that whereas if you read the textbooks on waterfall from the 80s and 90s, they're all about trying to make you not make mistakes. We're going to have all these design discussions up front. We're going to have all these meetings up front. We're going to plan in such detail that we can't possibly get the plan wrong, and that's how we manage risk. Okay, well, we tried that for several decades and it didn't really work. So what if you try the other side of the equation? Or in this case, the other side of the term, right? The other term in the product is, let's drive the cost of failure so close to zero that the amount that we screw up almost doesn't matter. And that's where things like test-driven development, replanning every week, releasing every 2 weeks, meeting every day, getting thin slices of features into customers' hands quickly so that we can then iterate and converge towards what they really want. All those ideas are based on the notion that if we drive the cost of failure down to zero, then we can fail safely. It's the thing I think that people forgot they mean when they say move fast and break things. The whole point of moving fast is if we work in such short bursts that the cost of getting things wrong is almost zero, then we can break as much as we want and things will be fine, as long as we learn from what we break. And as long as that helps us run a better experiment next time. And so that idea was another one of the really key elements of the economics of software development. Not only the whole, you know, you can take a head start, but then you hit the brick wall pretty soon, or you can start more deliberately and sustain growth better, as well as this idea that there are two main parts of managing risk. One is driving the probability of failure down to zero, which means don't make mistakes. Good luck. Or driving the cost of failure down to zero, make mistakes irrelevant. Make mistakes into experiments with outcomes where we just learn from what we try something, we learn from it, and we do better next time. And we converge towards solutions that work. That to me was really one of the other key points of that talk that I think makes it work.
Yeah, I keep going back to your rock climbing analogy. I've kind of been mulling it over in my head a little bit. Something you said that kind of struck me is it seems like you could go faster if you didn't stop to place any gear and you didn't use a rope, right?
Yeah.
And in some ways that's true because stopping to place gear takes time. But also, though, if you're climbing without a rope, you have to be slow and deliberate because you're worried about, right? You're not as free, like you can't like jump for a hold or something because you're like, oh, that's low. There's a low probability move and I don't want to fall. But if you place the gear all along, when you are climbing, you're freer to move faster because you don't care about making the mistakes, which kind of seems like it dovetails with exactly what you're saying about TDD and all of that.
Absolutely. And it really reminds me of, I read Nancy Klein's A Time to Think a few summers ago. Lovely book that talks about essentially a particular kind of coaching technique that she calls a thinking partnership, where it's like a mutual coaching partnership that's really based on what she calls paying exquisite attention. All that's just to say nice things about the book. The key thing in there, though, is at some point, as you're listening to the other person tell them what they're struggling with, you gather a bunch of information, and then eventually you need to ask incisive questions. These are the questions that sort of help the person take all the good stuff that they've told you, which gives them clues about how to solve their own problems, and then sort of helps them think about them in a moment of insight where they can then answer their own question. That's sort of the idea. And one of the kinds of incisive questions is, well, what would you do if you knew you couldn't fail? So if you come to me and you tell me that you're struggling with having conversations with your manager at work, I'll let you talk for 20 minutes. You'll say a bunch of things that'll give you clues about what to do. And then at some point, I'll ask you, well, how would you talk to your manager if you knew it wouldn't go bad? If you knew it couldn't go bad? And that, most people don't even consider that possibility. Like how would I actually behave if I knew things weren't going to go badly? Not because we're never going to make mistakes, but because I want them to connect with the aggressive part of their work, the aggressive nature of how they want to do their work. Bold. I don't mean aggressive like harsh, but I mean like bold, confident, that kind of aggressive. And a lot of the times we don't work that way because we've been trained for our entire careers that everything is broken and nobody seems to mind and nobody ever makes progress and good communication only happens by accident and so on. But how would you behave if you couldn't get it wrong? And that's, I think, the attitude that rock climber gets from all the safety features that they put into their ascent. Just like when we do things like test-driven development or weekly planning or daily stand-ups, it's not about micromanagement. It's about making mistakes so irrelevant that you can become bold and confident and work as though you had all the time in the world and you were never going to get it wrong. That everything that you used to think of as a mistake was just a little blip along the way that cost 10 seconds here, 2 minutes there, isn't a big deal, that you can recover from all these little mistakes quickly and easily. And that leads to a kind of confidence and boldness and aggressiveness that a lot of the people in our industry only ever experience when they're in such a crisis that the cost of failure is so high that nobody cares anymore. That's a pretty stressful way to work. I would rather connect with those feelings in a situation where the cost of failure is so low that I don't have to worry about it. That gives me the boldness and the confidence with a hell of a lot less stress.
So let me describe my experience with TDD because I think it speaks to this. So since I've started doing TDD, I basically spend almost zero time in the debugger.
Yeah,
Like
that was the first thing that happened to me too when I started. That was the first thing I noticed.
it was so freeing that like I run the code, it doesn't work. I look at it for literally not more than like 30 seconds. If I can't spot the problem immediately, I almost always just throw it away and start over. And it's so
Yeah,
freeing just to be able to do
yeah.
that. Yeah.
And one of the funny things is that, I can't guarantee that for all people all the time, that's cheaper than what they used to do, where you would, go into a trance, write code for N hours, and then run through the debugger until you got it right. Because some days you got it right, and some days you got it horribly wrong. You never knew how much time you're going to spend in the debugger. And a lot of times, writing code and then having to fix it 2 or 3 times is actually not that bad. Like, sometimes we're really close, especially when I work in environments where I don't have a good testing library to fall back on, or where building some kind of testing library would be too much work. Yeah, I mean, I hack on code like anybody else does, but I feel, I still feel that pain in my chest. It's not as sharp as it used to be, but I still feel that dull ache in my chest when I write a bunch of code and I'm not sure if it's going to work until I run it. And even when I'm working in environments without automated tests, I still write a tiny bit of code, run it and check it by hand, run it a little bit more code, write a little bit more code, run it and check it by hand. I still find such comfort in the safety that comes from those tiny steps. And if I can write automated tests before I write the code, the production code, then, that's just a different kind of calm comfort from, like I said, just running the code every few seconds to make sure the last edit worked. Um, like I said, I can't guarantee that that's actually cheaper for everyone all the time, but it really does seem to be cheaper for most programmers most of the time on average. And so it doesn't surprise me. I've heard it dozens of times over the years from people who say, when I finally sat down and started to write the tests first in a real high pressure environment on my day job, or on code that I really cared about getting right and getting done soon, once I got over the initial hump of how slow it felt, I was amazed that when I thought I was done, I was actually done. As I went along and I thought I was making progress, I was justified in my confidence. And once I got past the first couple of tests, it was kind of boring, but like the right kind of boring, the kind of boring that it should be. We should save our energy for the parts of this job that are really hard, like talking to people. And when it comes time for me to have a conversation with the computer about how to turn my thoughts into code, like that part should not be hard. That part should be easy by now. We've been practicing this for like 70 years. We should be good at it by now.
Yeah, that's very interesting. I I did Yvette's lean poker the other day,
Mm-hmm.
and
Oh, yes,
that
that's
was
right.
yeah, it was very interesting. I went in thinking I would do all the TDD and this and that, and
So did
actually,
I.
well, I did not, and I was with somebody
Oh,
else, and
yeah.
they didn't even know poker, and they didn't even know Python, and I was doing it Python, and I'm not a Python programmer, and
Oh,
it
excellent.
was challenging at first, but we didn't write tests, but we did get the feedback. So we were like
Yeah.
very quick on like push it, watch it. Oh, the number went down. Great. Revert it back, try something else. And that worked really well. And it was I think it's the speed of the feedback and also taking the small steps is also very, very important.
Yeah, this is something I think that Kent Beck has done a really good job of making it a little bit more formal and a little bit clearer over the last 5 to 10 years. The whole 3x model and the difference between being in the explore phase, the expand phase, and the extract phase really put a lot of the ideas from extreme programming in their proper perspective. Like if you're in the explore phase, if you're just trying to figure out if there's a product here, I'm not sure TDD is so wise. In fact, I'll say it more strongly than that. TDD is a waste of time and energy unless that is how you have to work. unless that is literally the fastest way you can write code. But for most people, most of the time, especially trying to learn TDD in that environment, is not just a waste of time, but probably a mistake because they're focusing on the wrong thing. And lean poker, like when you're in there and your bot is playing poker and getting trashed by the other teams, that is not the time to try to write an automated test. That's the time to figure out what's the thinnest slice of poker playing we can build. And a beautiful thing happens when you realize that just like not folding right away is enough to get started and win some hands. That's such a thin slice of feature that I don't think you need an automated test to write the one line of code to make that work.
Well, we gained
So-
that the very first time.
Yeah.
It was the very first like 10 seconds. All I did was change the bet to 1,000 and pushed it, and we won like
Right.
100 hands in a row.
Yeah.
Because everybody
And
else
that's-
is by default folding, and I'm just like, let's go all in. Like, who cares what
Absolutely.
we have? Yeah.
That's part of the point is that when you are focusing, like there's two different kinds of tests, right? There's the programmer tests that we write to tell ourselves our code does what we wanted. And then there's the customer tests that we write, that we don't always automate them, that help us like converge towards what's going to solve the business problem. What do the users need? What is the customer going to pay for? And they're different kinds of tests. Programmers keep making the mistake of just thinking that they're tests and treat them the same. When your focus is on figuring out what you're trying to build and whether you have agreement with your customers that you understand what they're trying to do, like TDD is not helpful there. There are some people who have, experimented with acceptance test-driven development or story test-driven development, and they like it when they are formalizing the part of understanding features. Like once we've got over the hump and we understand the first 3 or 4 features, and now we're kind of getting on a roll, and we just want to be able to formalize our discussions with the customers so that they're less haphazard. Using customer tests in a TDD form helps because they're like a nice way of measuring progress. Every time we make another customer example pass, we're one step closer to being done with that feature. We're one step closer to, getting a payment from the customer. We're one step closer to making them smile at us instead of frown. But again, when you're focusing on just trying to figure out the first few slices, the first few scenarios, the first few things that you want to deliver to a customer, like writing code level tests, whether you write them first or last, is probably not a priority. Like again, if that's how you're comfortable working, great. It's once you've got over that initial hump and you've got a huge backlog of features and you just want to figure out how to then reduce the volatility in the marginal cost of features, get into that stage where now we're going to try to crank through the next 6 months of work and make trade-off decisions about which features come first and try to make sure that we don't ship stuff that's going to cause us to step over to stumble over our own feet. That's when those extreme programming techniques like test-driven development and weekly planning really become helpful. That's when you start moving more into the extract phase where like 3% efficiency gains are actually profitable. And you're not in the stage where you're just like swinging a dead cat and hoping to hit a feature that somebody will buy. At that moment, I'm not really sure that focusing on writing code as well as possible is our smartest bet. I don't want to use that as an excuse not to be careful. I want to use that as a reason to be careful at the right moments. To not be overly cautious when what we really need to do is to put a bunch of ideas into production and see if somebody will buy them.
Yeah, well, I think part of that too, the other thing I got out of the lean poker was observability and just knowing what's being used and what's not. And we made actually a really big mistake in that we pushed something that was broken and we immediately went into debugging mode when what we really should have done was revert it back to the previous version first, because we just fell off a cliff.
Yep, we did. We made the same mistake.
Yeah, and I didn't realize it until just now, like thinking about the graph. I'm like, oh crap, yeah. If we would have pushed it back, we might not have fall off the cliff quite as much.
Right, and even though that's a situation where TDD is not helpful, that's where the lesson that you mentioned moments ago about TDD is helpful, right? One of the nice things about writing a little test making it pass, writing a little test and making it pass, is once you learn to really take small steps, then when a test fails when it should have passed, when you expected pass but you get fail, like you can stop yourself from trying to figure out what went wrong. You can just go, nope, get reset hard, try again. And I have I have kind of, it's a joke that I use in my training courses, but it is actually how I work when I remember. And that is, if the test should pass and it fails, undo, try again. And if the test should pass and it fails, undo, try again. When the test fails unexpectedly for the third straight time, I'm too stupid to write code. I need to get up and walk away. Like, I'm tired, I need a break, I'm getting caught in the weeds, I'm looking too much at the details and not enough of the big picture, I'm lost, whatever it is. But I just say it as, I'm too stupid to write code right now. That's cool. We're all too stupid to write code from time to time. It happens. That's the time to get up and walk away. And the really important thing is, get up and walk away, leave the room, walk through a doorway somewhere, like go somewhere else. And you're going to be tempted. When you get up and walk across the room and put your hand on the doorknob, you're going to be tempted to go, oh, now I know what I did wrong, and try to go back and get it right this time. No, keep walking. Like,
because you'll do that about 5 times in a row.
Absolutely. And then a half hour or an hour will go by and you'll realize that you were actually too stupid to write code. You just didn't pay attention. I really find it helpful in that moment to just get up, walk out, and when you have that, oh my God moment, like that information's still going to be in your brain after you've made coffee. Go make coffee, make tea, pour yourself a drink, whatever it is you need to do, walk around the block. In 10 minutes, the idea will still be there. If you're really worried about losing the idea, write it down on a piece of paper, put it on top of your keyboard, and still leave. Whatever you need to do to give yourself 5 to 20 minutes apiece. And then when you come back, you'll probably figure out 2 other stupid things you were doing wrong, or 2 other bad assumptions you were making. And that little bit of emotional distance and time will help you come back to it more clearly. And then I'll bet you'll make a bunch of progress in the first 15 minutes after you come back. And again, you don't have to practice test-driven development to benefit from that advice, but writing the test first and not being able to make the code pass the test 3 times in a row is like, that's the context in which I learned the trick. So even if you're not practicing test-driven development in your daily work, the lessons that we learned from learning test-driven development, from learning test-first programming, continue to help. And that's the same whether it's test-first programming or weekly planning or integrating every day or whatever it is that we're doing to try to create a small feedback loop. And again, that small feedback loop is all about driving down the cost of failure. It's about making a bunch of small bets and not worrying about losing, because you'll win enough of them to fund you to keep going forward. That's really one of the central messages from the economics of software development, from the 7 minutes and 26 seconds, that the small feedback loop is what allows you to drive the cost of failure down near zero. And that allows you to work as though you can't make a mistake. If you knew you couldn't get it wrong, what would you do? You can actually do that.
Yeah, I would say that is the biggest mistake that I see software developers make, is they try to take too big of steps.
Yeah. And it's natural, right? This is actually one of the other bits that I do in my training courses that helps is, like, it's not really useful to stand up in front of a bunch of senior programmers and say, your steps are too big, you got to make them smaller. And that they'll still shrug, right? Or they'll be like, okay, again, cool story, bro. What am I supposed to do? More often than not, people don't realize the cost of taking these big steps, probably because they've never done anything else, and probably because they remember their successes more than they remember their failures. Their spectacular failures are the war stories they get to tell at conferences and parties and networking events, so they're fun. But other than that, they tend to remember their successes more than their failures. They forget how much time they're wasting spinning their wheels, and that how often they spin their wheels because they take big steps. So, okay, cool. What are we supposed to do? Well, there's good news. There's one simple thing that you can do to help deal with this problem that doesn't require reading books. It doesn't require radically changing the way you work. It just requires one simple idea, and that's building a self-regulating system, right? A self-regulating system is a system that sort of oscillates between two extremes. And, in normal mode, it moves towards one end of the one extreme. And then in, let's call it careful mode, it moves to the other extreme. And our only job is to figure out what careful mode is like, so that when things go wrong, we ratchet up how careful we are until things get better. And then when things get better, we get bored, we get complacent. So then we take our foot off the gas a little bit, and then things get worse for a while. But like acceptably worse. Not bad, just not as good as they could be. Because our natural laziness, our productive laziness, human nature, whatever you want to call it, our normal mode of operation moves towards one extreme, and then when we're careful, we yank ourselves back towards the other extreme. So, like, how does that work in software development? Well, one thing we can do is, if our customers keep telling us that we're shipping the wrong thing, like if they're dissatisfied with the features when we show them to them, then we need to show them smaller features more often. Human nature, our conditioning, encourages us to try to ship bigger features because we think bigger features are going to be more impressive, and because business people keep telling us, well, I don't care about it until it's all done. I can't use it until it's all done. It's not valuable until it's all done. That's the whole like business value discussion. Oh, it's not valuable until we have 100 pounds of it. Okay, fine. Then we won't ship you anything until we build 100 pounds. But then when you wait 3 months and ship them the thing, and they tell you the 37 things they don't like about it, well, if you'd known 8 of those things in the first week, you could have got them something that they could actually use sooner. You would have avoided wasting a lot of time building stuff that they don't want anyway. So the self-regulating system comes from, okay, if the symptom is customers whine about what we ship them, and that can be whether it's a real customer or product manager, it doesn't matter. But somebody whines when we ship them the final product. Okay, well, if they whine too much, then the best thing we can do is to ship them something smaller so that they can whine sooner about smaller things and we can fix them sooner. And so now we have a self-regulating system. Most people, most of the time, will want to ship bigger features because they're more impressive and because people say that's what they want. But the problem is they might whine too much about what they're getting. And their whining is justified. Like, it's wrong in 37 ways. Cool. Let's then try shipping them something smaller and sooner so that we can get 4 of those complaints in the first couple of weeks. And maybe in the process, we'll end up avoiding 3 of the complaints they would have given us if we'd waited 3 months. So you can now see how sort of the self-regulating system works. Human nature pushes us in the direction of shipping bigger features. Whining reminds us to ship smaller features. When we ship smaller features, there's less whining. The whining is more helpful. The complaints are actually useful feedback. We get that feedback in time to actually do something with it. Everybody's happier. But then we go a few months without making a big mistake, without hearing a big complaint, without hearing a customer whine. So then we naturally start moving back in the direction of shipping bigger features because we're emboldened and we're confident and we're complacent and we start making mistakes. And that's how the system regulates itself. We don't have to do anything more than adopt the rule that says if the customer complains too much, we have to ship smaller features until they stop complaining. Because we know if they stop complaining for a while, gradually we'll get complacent and start shipping bigger features, and then eventually they'll start complaining again. And that's the self-regulating part. One simple rule. When they whine, we ship smaller features. When we have bugs, we start writing code in smaller steps. When we design ourselves into the corner, we have to refactor more often. One simple rule. You adopt one simple rule that says when the bad thing starts to happen, we have to do this thing more often. And that's it. We don't have to have elaborate ceremonies. We don't have to do any of that extra stuff. It's as simple as we find one rule that kicks in when the bad thing starts happening, and then the system regulates itself. We can just converge towards a happy place from there.
I feel like I've been doing that without actually being able to put it into words, which is great.
Yeah,
My rule, I don't know if you know, the Mikado method, does that ring a bell
yeah,
to you? Yeah.
absolutely. Yeah.
So for those who don't know, basically it's a way to take like a big task and break it down into a bunch of small tasks. And I don't use it regularly, but as I'm going along, if I start doing something, as soon as my brain goes, oh, this is way more complicated than I thought, or oh, this is taking way longer than I thought, I immediately just stop, throw everything away, grab a notebook, and start doing the Mikado method. And it just gets me right back on track.
Right.
And
And you
then,
don't even
and
have
I'm,
to,
yeah,
yeah. You don't even have to go Mikado method at that point. What's important there is like the higher level idea is when I notice myself getting lost, that's when I actually need to plan more.
yeah,
Whether that's Mikado method or Pomodoro technique or
yep,
anything else, some combination of I need to take smaller steps and I need to work in shorter bursts. And of course, those two things go together. So the really nice thing about that is now I don't have to I don't have to stand up in front of a room and teach Pomodoro technique on day one. I can wait until people in the room start complaining about, oh, I'm getting lost. I'm trying to remember too many things at once, or I'm shaving yaks and it's starting to be annoying, right? I'm now 5 yaks deep and I don't even remember what I was doing. Okay, cool. Stop, back up, start again, write things down more. And what I really like about this way of introducing ideas to people is the very common complaint of, oh, JB, that sounds great in theory, but in the real world, it'll never work. That complaint tends to go away because now every little technique that I want to add to people's plate, everything I want to teach them, every trick I want to show them comes up in the context of when they're experiencing the pain right now. And it becomes harder for them to object because they're feeling the pain right now, and I'm trying to give them the medicine right now. Now, the bad news is I never know what things we're going to learn in 2 or 3 days together. The good news is whatever they do learn, they'll actually use. That becomes the things that they'll actually use. So the bad news is the person paying for the training might not get what they think they paid for. But the good news is the people in the workshops, whatever they learn, they'll actually use because it came up in the context of when they needed to know. And therefore, it becomes immediately compelling. I don't have to sell them on something before they're ready for it. I don't have to try to change their mind about I don't have to change their life philosophy. I can just hit them with a trick that helps them in the moment. And then if they're interested in knowing why it works, then we can have the interesting discussions about, well, I'm lowering a feedback loop, or I'm trying to reduce the time between when we make a mistake and when we find the mistake, or here's this theoretical principle about bottleneck theory that can help you understand why this works. I also don't want to teach people tricks that feel like magic, that they have to sort of figure out when to use and use them and they don't know why they work. I want people to know why these tricks work. But by learning them in context to solve real problems as those problems are coming up, they're much more likely to actually make use of this stuff than they would be if they just read a book that told them, here are 13 practices that will help them, or here are 5 tricks they need to learn. You need to get better at this, you need to get better at that. It just sounds like so much eat your vegetables and you'll be healthier. Sometimes people need to get into trouble before they're ready to listen to the advice that will help them avoid trouble next time. Let's go with it, man. I mean, that's part of what makes these talks particularly nice for me is that all the time that we've spent waiting for people to get in just enough trouble and cry just enough in pain to receive the solution at the right moment. Like when we see patterns in that, then those become the 3 to 5 bullet points that become the talk that can be, interesting at conferences. And then when you feel the pain, if you happen to remember my name among the many names of people who you saw talk about this at some point in the past, that's good for business.
yeah. There's one piece of advice that I heard you give to somebody, and I repeat it all the time. And it's often you hear people who are like, "Oh, our code's too hard to test."
Yeah.
Right? And one of the things is like, "Oh, okay, well, when you have a bug, write a test to catch the bug." And that's good advice.
Yeah.
But the problem is people are still like, "Well, my code's hard to test. So like how do I
Hmm.
write a test to find this bug?" And I think the advice you gave was set a timer and just try to write a test. And with no expectation that you'll actually be able to or not, but that just the act of doing it starts to build that habit. And even if you don't write the test, you learn a little bit about, well, what makes it hard to test. And at least then in your brain, you're kind of associating those things. And then you're learning, like, as you write new code, you're going to write code that is easier to test because now you know, like, okay, these things make it hard to
Yes.
test. Let's avoid that.
I think so I'm glad that that stuck. And yeah, I call this casino technique, right? The whole idea of you figure out how much you can afford to lose, um, frame that as entertainment money, and then spend it in good conscience. It's kind of what happens when you set the timer. When you say, look, I don't know if I can do this, but I can spend 15 minutes to find out. Okay, cool. Like that frame of mind feels a lot different from, oh my God, I'm about to open a whole can of worms and I don't know what's going to happen. I better not start. Or once I get started, I have to finish. The whole, we don't roll back, we roll forward. Like those attitudes are sensible, but I'm not sure they're helpful, right? They're different kinds of fear that in a crisis maybe are sensible and rational, but as everyday living, I mean, we don't have to live this way. We don't have to live in constant fear like this. And so framing it as I can afford to spend 15 minutes to find out. Nobody's gonna yell at me if I spend 15 minutes trying to do this. And as you say, in 15 minutes, you'll learn something. Even if what you'll learn is, oh my God, I don't want to make the same mistake next time. Or now I understand why they make such a big deal about immutability because this one stupid side effect here is the only reason I couldn't write a test in 15 minutes. If only this one side effect were out of the way, my problem would be solved. Okay, cool. Guess what? There's all kinds of articles on the web about how to get side effects out of the way. There's entire books on the subject. Or you can just learn one or two simple tricks to get started figuring that stuff out. Um, and if 15 minutes went by and nobody yelled at you, then you could always set the timer for 15 minutes again and try again and keep going until somebody yells at you for taking too long. And then maybe next time you can feel emboldened to try 30 minutes or an hour. But you're not making a huge commitment to something that might fail, right? You're setting a boundary on your commitment so that when you get to the end, yeah, you might feel a little bit of shame even for not being able to do it. But that passes pretty quickly. Like you didn't expect to do it. You weren't sure if you could do it. Success wasn't guaranteed. That's cool. What did I learn that will help me next time? And as you say, even if all you do is establish a habit of running small experiments and not feeling devastated by a failed outcome, if that's all that happens, that's already a huge win. Like that's going to help you not just feel better about the work you're doing, but it's going to help you bring more energy and it's going to help you bring more energy to the next task and it's going to make it more likely for you to succeed. You're going to be in a better frame of mind to do the next thing. You're not going to wallow in self-pity. You're not going to feel like a failure for hours and just make your mistakes worse. You'll say, okay, didn't work this time. Cool. We'll try again next time. At least now I know why that side effect of writing data to the database is such a problem, or why these two things shouldn't have been split across a distributed microservice boundary. That becomes much more concrete, helpful advice than motherhood and apple pie statements like write tests or refactor or work in shorter chunks. Like those things are true, but they sound true but useless until you're in the moment where you now regret not doing it in the past. I want to make that, that's one thing I think is that Adam Grant or Daniel Pink? The Power of Regret. I forget who the author is, but that idea of regret as being a powerful motivator. It's not like I want you to feel regret, but since you're going to feel regret, you might as well benefit from it. Like, if you regret this, then that is the reason not to do it next time. That's the reason to find the rule. That's, again, that self-regulating system idea. It's not about telling you the theoretical thing you're supposed to follow because it's a good rule. It's about figuring out the rule that helps you get away from the pain. Okay, I need this rule now. Whether that's writing the test sooner or starting fixing a bug by writing a test first. And if you can't write a fully automated test, then at least write a repeatable manual test and keep running the test manually until you can do it without thinking. And as soon as you can do it without thinking, you've probably made it repeatable enough that you could automate it. Cool. Set the timer for 30 minutes and try, see what happens. Or even the higher level idea. When you're not sure if success is guaranteed, then take a moment, figure out how much time you can afford to lose, set a timer for that amount of time, and just see what happens. And if you end up throwing all that time away, that's okay. You started by saying, I can afford to waste 30 minutes on this, but no more. Then cool, let yourself waste the 30 minutes. You'd be surprised how often it's not a waste.
Yeah, I think that starts out with and it ties back into the rock climbing and stuff of making it safe to experiment. Because you've already decided. And there's a training thing called like the Rock Warrior's Way or something. And part of it is before you set out climbing, you look and you're like, I'm going to fall. If I fall, I'm going to fall 30 feet. And in your brain, you have to tell yourself, I'm okay with that. And once you do, it's because until you say that, you are worried. You're like, oh my God, I'm going to fall. I'm going to fall. And once you decide like it's okay, your brain just like stops thinking about it. You're like, okay, yeah, I'm going to go do this. And it frees up a ton of mental space.
Yeah, and I think this is one thing that most people in the software world forget, that like we're constantly under pressure to perform better than we've ever performed before. Or at least we're under constant pressure to perform at 100% all the time. I don't know, I've been saying this for over 25 years now. I don't know why computer programmers in particular think they're the only industry in the world that doesn't need to practice anything. Like everybody else rehearses or practices, does dry runs, they do practice drills, and computer programmers think they don't need to. And that's just nonsense. You can benefit from drills. And things like, I'm going to spend 30 minutes and try to write a test, or I'm going to spend 30 minutes and run an experiment. Like you're not just doing the task, but you're practicing building safety into your work habits. You're practicing the experiment as a technique. You're building the habit of running the experiment instead of just judging the wind and then running headlong and hoping you make a good choice. These are things we need to practice. And the good news is we have a lot more slack to practice these things in our day job than we think we have. Because as soon as you have to wait for somebody else, you can afford to run an experiment while you're waiting.
Yeah, so that's an interesting take. Like, yeah, there's a lot of like downtime and waiting. But the other thing too, and actually software developers always have an excuse. Oh, it's building. Oh, it's compiling, right? I'm waiting for this or that. But I read Trisha Broderick's book and Diana Larson, I think it was, Lead Without Blame. And one of the things they said in there that really stuck with me was like, and I've said this about unit tests and testing, like don't put it as a separate line item. Like don't think of it as a separate activity. It is the activity. And learning, we're doing knowledge work. Well, like learning is part of doing knowledge work because we're always doing something new. We're always expanding into new areas and we have to learn. Count that as part of the work.
Right. So this is, there's a flood of connections that go back to, books like Peopleware and the new product development. The idea that most of what we're doing is stuff we've never done before. Now, we've done things like it in other contexts for other businesses, with other people, in other technologies, under other conditions. But we've never done this before. Like we're trying to look for patterns, look for similarities between what we're about to do and what we've done before, and make good guesses about how to do this next thing. But very few of us spend most of our days doing a bunch of things we've done before with the same people in the same technology, in the same context, for the same customers, under the same conditions, for the same reasons. I'm sure there are some people out there who work that way, and I would be shocked if any of them ever found this podcast. That's typically not what we're doing. We are trying to do new things, and we need to make room. We need to not just make room for mistakes, but we need to learn how to recover from mistakes. And I think those two things are really what we're learning most when we learn a lot of these incremental and iterative approaches to software development. We're learning the two key strategies in managing risks, right? One is mitigating risks and the other is recovering from risks, right? The obvious way to manage risks is to never make a mistake. I still haven't worked on that project. I still haven't worked with those people. I don't know where they are. They must be somewhere, but I've never seen them. So what else do we have? Well, we try to see the risk becoming a problem, and we try to recover from the risk, right? If we see the risk becoming a problem, maybe we can use strategies that delay when that happens, that make it happen more slowly, that we take steps to try to avoid it from happening in the first place. But that's not the same as never making a mistake. That's recognizing when the mistake is happening and figuring out how to correct course as we go. But eventually we are going to make the mistake, and we need to learn how to recover. And a lot of the techniques that we've been talking about, the techniques I talk about in the economics of software design, in 7 minutes and 26 seconds, in surviving your inevitable agile transition, a lot of these are about figuring out how to see the mistake coming so we can stall it, or to let the mistake happen and recover from it. Excuse me. To see the mistake coming, let it happen, and recover from it. Recovering from mistakes is surprisingly powerful. It's okay to make mistakes if we can recover from them and move on, get back on track. And part of the reason to take smaller steps is to make smaller mistakes. Part of the reason to deliver sooner is to make smaller mistakes. Part of the reason to write tests first is to make smaller mistakes. Not just because they hurt less, but because we can recover from them sooner when we make them. And gradually we reach the point where the mistakes are so small that we don't even think of them as mistakes anymore. They're just experiments and outcomes. And when they're just experiments and outcomes, all that emotional baggage that comes from making yet another mistake today at work goes away. And we have a lot more energy to bring to the next task. We work with a lot less stress. We work with a lot less guilt and shame. And that makes it a lot easier for us to work without blame. Not just lead without blame, but program without blame. Well, we knew we were going to get this wrong. That's why we wrote the tests first. We knew we were going to misunderstand the customer. That's why we wrote scenarios. That's why we're delivering stuff every week instead of waiting to do it every month. We knew we were going to get this wrong, so that's why we put something in production as soon as possible. That's the whole point, is we know we're going to get this stuff wrong. Let's figure out how to be a little less wrong today than we were yesterday.
I had this exact experience actually just last night.
I hate to leave you on a cliffhanger, but that's the end of part 1 of our interview with JB Rainsberger. Part 2 will be coming in about 2 weeks. See you then.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram @TheLVExperiment.